Let's do some interesting ones, huh? And by interesting, I mean a little more tricky, a little more involved than just it's 0 over 0, take a derivative, plug it in. Maybe we got something you gotta think about. Maybe a little bit of algebra first or something. I don't know. Maybe we'll introduce a new concept. So let's just jump right into it. It's got a few of these limits to evaluate. We'll just run through it. So let's take care of this first one. We have another infinity where we're going towards infinity. So at the top we have 5 raised to the power of infinity. Well, pretty sure that's going to go to infinity, huh? You know that exponential function? Well, it goes like that as x goes to infinity. I think that's going to take off. I think it might. I don't know. And then what about down below? Down below, do you think that's going to go to anywhere? So you have, when you plug the infinity into the x, right? And plug it in. You're not plugging it in. That's infinity. And then to this, that's infinity. So it's infinity times infinity. It's really, 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 really infinite. It's just big. Okay, we got infinity over infinity. It means L'Hopital's is ready to go. And there's a smooth way through this problem, and there is a horrible way through this problem. Now you could just take a derivative top and bottom of this sucker and just go. Or you could recognize that the 5 has the same power as the 2 has. They're both raised to the power of x. So if we were to do maybe a little bit of algebra beforehand, no L'Hopital's, just a little bit of algebra beforehand, and we put these two things together. 5 over 2 raised to the power of x. So we're going to get 5 over 2 raised to the power of x divided by x. I think that was a little bit simpler for us to do rather than doing a whole product. Now if we look at this thing, it's still going to be, if you were to plug infinity into the top, you would still get infinity. And if you plugged infinity into the bottom, and I'm saying I plugged in, right, big quotes. I don't mean that shit. That means we can do L'Hopital's. Let's go do L'Hopital's then, huh? Now we can handle this. This is just a simple, that's just our exponents rule, right? So let's take the derivative of what's up top first, right? And that's going to be, wasn't it just leave that shit alone and then multiply by the natural log of 5 over 2. Cool. Now what's the derivative of x? Yeah, that's 1. So where's this thing going? What's happening? Do you need to get your graphing calculator out and figure out what the heck is happening with this? With the limit is that x is getting as big as you could possibly think of 2.5 raised to the power of x times some other number that actually doesn't make any freaking difference if you pop out to the front. Well, I think since that exponent's going to infinity up there, and that this number is larger than 1, if it was less than 1, if that base was less than 1, it would have gone to 0. If that base was less than 1, it would have gone to 0. But this base it's bigger than 1. So, oh shoot, this thing is going to absolutely 100%, it's going to take off and go to infinity. So our solution for this would be infinity. It blew up without bound. Huh. Just because that 5 over 2 raised to the power of x, any exponential function with a base larger than 1. That's for some a to the x where your a is bigger than 1. All right, it's going to blow up, and 2.5 or 5 halves is bigger than 1. Next problem. Now this is a fun one. Oh, good. This is great, and it's going to introduce a concept to us. Now we're going to be able to. I'm going to do some fancy footwork to get around using this concept, but let's see what's going on. And we're like, hey, dude, there's no fraction here. But what do we have? What's going on here? If we were to plug it in, like I'm just going to write it in. It's negative infinity times. And what would happen if you put negative infinity into e to the power of? This is where shit gets weird, huh? Negative infinity. Well, if we know how to graph e to the x, this isn't a big deal. We're like, oh, there's e to the x. Oh, so as x is going to negative infinity, doesn't the height look like it's going to, what's the height going to? Isn't that 0? It's going towards an asymptote. Oh, cool. So I think what we have there is negative infinity times 0. So infinity times 0 means, it means this. Do more work. That's what it means. Infinity times 0, no. 0 times anything other than infinity is equal to 0. Infinity minus infinity means nothing. Infinity times 0 means nothing. It means do more work. Don't stop right there. Most common error through this shit. People see a 0 and they're like, that, done, 0. Don't do that. More work. So we can do some fancy footwork to this. We can play around with it. Now, I'm going to show you a quick substitution, and I'm going to run this one real quick. And we'll move on to the next. I want to substitute in, I want to say the limit as x goes to positive infinity. So all I've done is I've changed down here what the a is. I'm going to change it to positive infinity, not negative infinity, which means I need to change the signs on both of my x values. So inside this parenthesis, so instead of writing in x, I'm going to put in negative x times e to the, instead of writing in x, I'm going to write in negative x. Well, now that we've done that and done that quick substitution, just change the signs on both of them. They're still going to run to the same stuff. You plug it in, you're still going to get a negative infinity when you plug infinity into here, and you're still going to get 0 when you plug it into there. You will. So it's still the same thing, just did a little bit of fancy footwork, and then, oh, what happens when we have a, isn't this negative exponent? Doesn't that mean it's supposed to be down below? Doesn't it say, hey, move me down below? Sick. There we go. There we go. Now if we play this, we just did a little bit of frickin' algebra. Made our lives easier. Looks like we're going to get a negative infinity up top and an e to the infinity. Shit. Where's the end behavior of e to the x? It's graphed beforehand. Look right there. It's going towards infinity. So we got L'Hopital's case. Now let's go hit this thing. Let's go. L'Hopital's. Limit as x goes to infinity. The derivative of negative x is going to be negative 1. The derivative of e to the x is equal to e to the x. You plug that in, isn't the denominator going to get really freaking big, and the numerator is going to stay exactly the same? Hence, that is going towards 0, and 0 is our solution for this one. Huzzah! And let's see it again. We got ourselves another, well, don't look at number 4. Number 4 is not for right now. Number 4 is for later. So we got the limit as x tends towards 0, but we're going to do it from the right-hand side because ln of x only knows values of positive inputs. It does not understand 0 nor negative inputs, so it would have to come from the positive side. Otherwise, this problem would be what we call, yeah, that's nonsense. So let's look and see what sort of case we got going on here. What sort of just little case? No one thinking you plug in 0, you're going to get 0 for the first one. You get 0 times, and what's this? Is ln of x? Of x, doesn't it look like this? A little graph, so if it goes like, oh, we're going towards negative infinity. That's right. So again, we have this 0 times like an infinity case, right? So what we have to do is we need to do fancy footwork to it. Again, that means do more freaking work. Do not just say the shit equals 0. It happened to be 0 on the last problem. This one might be 0 as well. I promise you, if these two equal 0, and I notice that on your test, that shit will not equal 0. I'll make certain of it. So don't just fall into the fact that 0 times infinity is going to equal 0. It could equal 7. It could equal a trillion. It could equal infinity. It could equal all kinds of shit. So don't stress. Let's run through it. Now, here's the game. We want to create a 0 over 0 or an infinity over an infinity case. And the way we're going to do this is by the opposite. We're so used to doing something one way. What would we do if we had this? Just jumping aside and going, ln of x divided by 1 over x. What would you do with the denominator? Wouldn't it flip up and multiply? Wouldn't you take that thing and flip it up and multiply it, right? The natural log of x, and we'll take this thing and we flip it to x over 1. Isn't that how we do that? Well, why can't we go the opposite direction? And that's what we're going to do in this problem. We flip those denominators up. Well, we're going to go in reverse, do the same game. So we're going to do algebra first. The limit as x tends towards 0 from the positive side. And we'll leave the ln of x up top. But now let's divide by 1 over x. So there's our denominator, 1 over x, and our numerator is ln of x. Now if we were to plug this thing in and we're to see where we're going, this looks to be up top. That's going to be that's a negative infinity. And then down below, what's 1 over x is x tends towards 0 from the positive side. Well, that's 1 over x, right? So as x tends towards 0 from the positive side, looks like we're blowing up to infinity. So, oh shit, we did it. We've done it. We've gotten it. We got an infinity over an infinity case. Hallelujah. Let's run through this sucker. Let's take a derivative of top and bottom and see what the heck happens. Oh,
L'Hopital's saying let's take some sort of derivative on this. Top and bottom, no quotients needed. So the derivative of ln of x is equal to 1 over x. And then the derivative of 1 over x, x to the negative first power. So something like that. Sorry. So negative 1 over x squared. So this thing is equal to, doesn't that thing flip up and multiply? I gotta keep going down. Oh shit, this is gonna end up being 0. I'm gonna promise you, I'm gonna make a little promise. You are not gonna see 0 when you play this game on your test. You're gonna get 1 over x times, we flip it up on the other side, negative x squared over 1. This turns out to be the limit as x tends towards 0 from the positive side of just negative x. You put it in, the answer is 0. Uh-oh. Give you my word, when I give you your test, you're not going to have stuff that's just going to pop out to be 0 when you get this infinity times 0 cases, right? You ended up getting it twice right here. This is what we call, what we call a coincidence. And I didn't check these before running them through. Coincidence that 0 times infinity equals 0. Do not assume that it will equal 0. It can equal anything. You can make that thing equal the square root of pi by messing around with them enough. Now we'll mess with these next. This is going to be the infinity minus the infinity case. Infinity minus infinity, and that's going to be some nonsense. So we will be back with our next one where we'll deal with a couple of new indeterminate forms.